Hi everyone. Today we're going to evaluate more integrals using integration by parts. In our last video, we studied the steps to integrate using integration by parts. Here are the steps. You may pause the video and look for the steps one by one. For now, let us proceed to our examples. This is example 1. Use integration by parts to evaluate the integral of ln x over x cubed dx. For our solution, first let us rewrite the integral to be the integral of x raised to negative 3 times ln x dx. Now step 1 is, let us choose the function u and the function dv. Let us identify the category of our functions here. We say that x raised to negative 3 is algebraic, while the ln of x is logarithmic. Based on our acronym, the letter L for logarithmic comes first, then the A for algebraic. So this ln x is our u. So we write here u equals ln x. And the dv is that x raised to negative 3 along with the dx. Now step 2, we will take the derivative of u while take the integral of dv. So the derivative of u is du equals the derivative of ln x is 1 over x dx. For the dv, we will take the integral. So we will have the integral of dv as v equals the integral of this x raised to negative 3 dx. Using our power rule, we have the x raised to negative 2 over negative 2. Then we can simplify this fraction into negative of 1 over 2x squared. Step 3, let us substitute the values from step 1 into the formula of integration by parts. This is now the formula, and this left side, the integral of u dv, corresponds to our problem here now. And the right side here, we shall replace by values from step 1. So the u is now the ln x, and the v is replaced by this negative 1 over 2x squared. Then minus the integral of v, we now replaced by negative 1 over 2x squared times the du. Our du here is 1 over x dx, and we copy this value in here. Step 4 is to evaluate the integral. So for the uv, we'll just simplify the two terms. So we have now negative of ln x over 2x squared. And then the negative of this fraction and the negative sign outside becomes positive. We combine this x squared and x to be x cubed. Simplifying further, we can move this constant 2 in the denominator outside. So we have here 1/2, and then we show that this x cubed is written as x with negative 3 power, then the dx. Let us now evaluate this integral. So we have now 1/2 times the integral of this x raised to negative 3. We have x raised to negative 2 over negative 2. We can simplify this part into negative 1 over 4x squared. This is now the final answer. Example 2. Use integration by parts to evaluate the integral of x squared times e raised to 3x dx. For our solution, we go to step 1. Let us choose u and dv. Let us identify the category of our functions here. X squared is algebraic, while this e raised to 3x is exponential. With our acronym ILATE, the A for algebraic comes first, then the E for exponential. So our U here is the x squared. So we write U equals x squared, and the dv equals e raised to 3x dx. Step 2, we take the derivative of u while take the integral of dv. Derivative of u is du equals derivative of x squared is 2x dx. Now the integral of dv, and we will get the v equals, for the integral of e raised to 3x dx, we have a special formula for this integral of exponential. We have this integral of e raised to ax plus b. This is equal to e raised to ax plus b all over a, then plus c. Now for the integral of e raised to 3x, we have e raised to 3x over 3. In the integration here, we don't write the plus c. Step 3, we substitute the values of step 1 into the integration by parts formula. Our problem here of integral x squared times e raised to 3x dx is equal to the integral of u dv. Now let us substitute the corresponding values of the right side. The uv is equal to the x squared times the e raised to 3x over 3, then minus the integral of v. Again, we write the e raised to 3x over 3 times the du. This time, our du value is 2x dx, so we copy it here. Step 4, let us now evaluate the integral. For the ub, we just put them together. So we have the x squared times e raised to 3x over 3. Then minus, we simplify first the integral here by pulling out the constant outside the integral sign. This 2 and 3 is 2/3, and it's now written here outside the integral sign. So what remains here is the integral of x times e raised to 3x dx. Please observe here that there is no direct formula for the integral of x times e raised to 3x dx. In this case, we're going to do integration by parts again. We will take the u to be this x and the dv this e raised to 3x dx. We take the derivative of u as du equals the derivative of x as dx. Now, the integral of dv. So this is now v equals the integral of e raised to 3x dx is this value e raised to 3x over 3. Let us now substitute these values in the integration by parts formula. So we have now the uv here is x times e raised to 3x over 3. Then minus the integral of v is now e raised to 3x over 3 times du. Our du here is dx, so we write it here. We combine the uv to be x times e raised to 3x over 3. Then minus this constant 3 in the denominator, we pull it out outside the integral sign. So it becomes 1/3. So we have now this integral of e raised to 3x dx. We can use this formula here. So we have now this integral to be e raised to 3x over 3. Let us simplify further the expression here by multiplying these 3 and 3. We have now e raised to 3x over 9. This answer here is the answer for this integral in here. It means for our final answer, we will write again this problem, and then we will copy this fraction we write here, then minus the 2/3, and it's here. Now this whole expression here, we will substitute to the integral of x times e raised to 3x dx, and it's now here. Let us simplify further by multiplying this fraction to the terms inside the grouping symbol. So we have now this minus 2x e raised to 3x over 9, then plus 2 e raised to 3x over 27. This expression, there is no change. We just copy from the first line. And from here, we will add the plus c. This is now the final answer. I hope you learned something from this video. See you again next time.